everyone, today we're going to talk about the sine rule. Now the sine rule involves two sets of pairs. So to know whether we have to use the sine rule, we need to look to see whether we have a side and a directly opposite angle and another side and its directly opposite angle. Now when I say we need to make sure that we have them, I mean that we just have something, a piece of information in that spot. So it could be a number to tell us how long a side is. It could be the size of the angle. It could be theta to represent a missing angle that we have to calculate, or it could be a letter to represent an unknown side. So when I say you need to have two pairs, like matching pairs, that's what I'm talking about. So see how I've got nothing written up here? There's like absolutely no information. I'm not using that side whatsoever in this question. Same as over here, I'm not using this angle up here because there's no information about that angle. And they need to be directly opposite one another. So I need to be making sure that it's the exact pairs that I have. If I had a side up here and I had a missing angle down here, I'd have to do some other calculations to find the size of the angle, because obviously the three angles add up to 180. But anyway, that's not what we're talking about right now. We are talking about how we use the sine rule. Now, when it comes to the sine rule, the HSC reference sheet, it says A over sine A equals B over sine B equals C over sine C. But we don't really need that last bit. That's just, don't know why that's there. It's just there. You don't need it. All you need to know is A over sine capital A equals B over sine capital B. Now the little a represents the side and a capital A represents the angle. So let's go ahead and label these with the A's and the B's. So the little letters represent our sides, so let's make this one A, although it doesn't matter whether it's an A or a B. We just have to make sure that it matches with its directly opposite angle. So we've got little a, capital A. That means this is little b, and you guessed it, capital B. All right, now we're going to put these into our formula. Now, there are two different versions of this formula. We've got the little letters on top, or we've got the capital letters on top. You are putting on top whatever you are missing. So if you're missing the sides, you're using this one with the little letters on top. If you're missing an angle, it's the capital letters that you want to be at the top of the fraction. In this case, we're using this one because we are missing a little a. Alrighty, so we're going to fill in these blanks with whatever numbers we have here and try and solve it. So let's do that over here. So little a is just, leave it as little a, over sine capital A, which is 64, is equal to little b, which is 13, over sine capital B, which is 54. Okay, now we want to get little a on its own. So we have to multiply. So we're going to multiply to move it to the other side. So what this means is it'll be a equals 13 over sine 54 times sine 64. So we're just picking this bit up and we're moving it over to the other side. Pretty much we're moving it to the end. Yeah. And we're timesing it. All right, so let me get my calculator. Okay, so I've got my calculator. Let's try this, typing it in. We're going to go 13 over sine 54, close our bracket, move to the side, times sine 64 equals A equals 14.4426, blah, 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 blah. Let's round to two decimal places, because two decimal places is always a good number to round to if the question hasn't specified how many to round to. So we count out two spots, put a dotted line, just two round up or down, rounds down, so that means they just drop off. So A is equal to 14.44. And then whatever units, I don't know, these might be meters. So this becomes meters. If there's no units in your question, you don't have to worry about putting units in your answer. But anyway, moving on to this one. What's different about this question is that we're not looking for a side, we're looking for an angle. So same deal, we're going to start by labeling with little a and big A, little b, big B. So let's make this one over here little a. That makes this capital A. And this one over here is little b. And this one over here is capital B. But they're interchangeable. It doesn't really matter which one's which. My floor is very squeaky. Okay, so now we're going to put at the top of our fraction whatever we're missing. So in this case, I'm missing capital A, so I'm going to use this formula here instead. So let's use this formula. We're going to go sine capital A, which we don't know, so sine theta, over, or I can just leave it as sine A, whatevs, over 43 is equal to sine 33 over 25. Now, just like before, I have to move my unknown to the other side. So this, I'm going to pick it up, bring it over here, and I'm timesing. So now what it says is sine angle equals sine 33 over 25 times 43. Now I'm going to type all of this into my calculator, but first, because I'm trying to find a missing angle, there's a special button that I'm going to push on my calculator first. I'm going to push shift. Then I click sine, and it will give me a little -1 on my calculator. Then I can type all of that in, and it will tell me the size of my angle. Now the reason why we push shift is so that we can find an angle on the inside. It gives us inverse sine, meaning inside, meaning we're trying to find an angle on the inside of a triangle. So shift, sine, it'll come up with a little -1. Then we type in all of this into some brackets, and it will tell us the size of our angle. So shift, sine, bracket, sine 33 over 25 times 43, close our bracket, and we get sine, we get our angle is 69.517504, blah, 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 blah. Again, let's round to 2 decimal places. So I put a dotted line after 2 decimal places, 7 rounds up. So that means this will become, the size of the angle is 69.52. Now, sometimes you can get challenge questions. Let me show you what I'm talking about. Let me get rid of this one here. Make some space. Sometimes it will say it's an obtuse triangle, or it's something like that. It'll say the word obtuse. Now, you can see from this picture here that I do have an obtuse triangle. Now, mind you, I don't draw my pictures to scale. Usually your pictures in exams aren't to scale, unless it says so. But you can see that it is an obtuse angle. So the secret is, if it says anything about obtuse in your question, you have to do this next step. You're going to go 180 minus whatever answer you got. And then that will be your answer, right? So 180, take away whatever answer you got here, and that'll be the answer if it says the word obtuse, okay? So the word obtuse tells you, take your answer away from 180, and you get the answer. Okay, so let's do that. So our answer was 69.52, so 180 minus 69.52, 180 minus 69.52, 180 minus 69.52 gives us 110.48 degrees. Oh, and this is degrees down here. Now you only do this step, this last bit, if it's a challenge question that says the word obtuse. If it doesn't say obtuse, don't do this last step if it's not obtuse, okay? Only minus it from 180 if the question has the word obtuse in there. Otherwise, You are just stopping here, and that's how you use the sine rule. Thanks for watching.